What's up, math scholars? Thanks for joining me. Today's Tuesday, May 15th, and I'm at Solder today having fun with my son in Poetry Cafe, so that'll be good. I'll be back tomorrow, so don't be too sad. We are going to start this video with a warm-up, so go ahead and jot it down and use that Trig identity sheet to help you maybe verify this following identity. We can have the sub hit pause, and you all can work a few minutes, and then when you're ready, you can click play, and you can check your answers, okay? Hopefully you're having a happy Tuesday. All right, you're back. You ready to check? So just a reminder on these, identities, just a reminder, you want to pick one side and work on that side only and kind of make that side match the other side. So I'm going to pick my left-hand side, work on my left, and work until my left-hand side matches my right, and then I will be verified. Let's start over here on the left. I'm really looking at this cosecant right here, and I'm thinking that we can replace it with its equivalent form. So do you have your trig identity paper out? All right, I had to grab mine, but you can see at the top that cosecant under reciprocal identities, cosecant equals 1 over sine. So I'm going to make that first replacement. I'm going to replace cosecant with 1 over sine. So I'm only working on the left, so my right-hand side I can just remain unchanged. My right-hand side is cotangent x. So hopefully you're seeing how this is going to work out very easily here. The sine is going to cancel the other sine, leaving me with 1 over tangent x on the left. And then if you look on your paper, 1 over tangent is the same thing as cotangent. So I can replace this 1 over tangent with a cotangent. I'm not going to match what I've got on the right, which is awesome. So we have verified the identity at this point. Okay. All right. We are ready to start the lesson then. So I will check the homework when I return. So just kind of keep a hold of that until Wednesday. We're going to do 10.4 solving trig equations today. There's not all that many problems. It won't take too long, but I do need you to dig a unit circle out. So look in your folder. I don't know how many days it's been since we've used it, so I don't know where you've put it, but dig your unit circle out for today's lesson. If you need to pause and do some digging, you can. And hit play when you're ready to join me. So there's my trusty unit circle. We're going to be doing all our work in radians today, so be prepared for that. Before we start, I do want you to write down these two equivalent fractions. If you ever get to the point and you're solving one of these equations, we're solving equations today. 1 divided by radical 2 is the same exact thing as radical 2 over 2. One of them has just been rationalized. So they both have the decimal equivalent of 0.707. It's just good to recognize that 1 over radical 2 is the same exact thing as radical 2 over 2. And that number should look familiar because it's on your unit circle. All right, this just kind of chats that we have verified trigonometric identities before, but in this lesson we will solve trigonometric equations. And it says to see the difference, consider the following. Sine squared x plus cosine squared x equals 1. That's the Pythagorean identity, one of the most famous trig identities, and that is true for all values of x. Now equation 2, sine x equals 1, that's only true for some values of x. In fact, let's talk about which values of x that would be true for. Sine x equals 1. So we're basically looking on the unit circle for all places that would have a sine value of 1. Go ahead and look on your unit circle and see if you can find any places that would have a sine value of 1 or a y value of 1. There's only one. It's up here at 90 degrees or pi over 2. So our answer for this one would be pi over 2. Now, we have talked that if you would take yourself and spin another 360 degrees, or 2 pi radians, you'd be back at the same exact spot. So we're going to have a tagline today, and this is like a little awkward, but you'll get to learn it, to use it and love it. You will put plus 2 pi n, and that just means you can add 2 pi as many darn times as you want, and it's not really going to change your location on the unit circle. So it's almost like you will just add that tagline to every single solution you get, to every sine and cosine problem. Right? Okay, we are set to solve our first trig equation. So we're going to solve it with normal algebra, and at the end we're going to look at our unit circle for a place that has that value. So let's start by just adding a radical 3 to get him over to the other side. I guess I should have paused a little longer to allow you to jot the equation down. If you need to hit pause at any time during the video and rewind, feel free to do it. At this point, we will take our 2 and divide it over to the other side. And now we've reached the point where we head to the unit circle. What we know to be true is that sine of x is radical 3 over 2. That basically means look at your unit circle. Maybe I'll even write this out. Look at unit circle and find all places that have a sine value of radical 3 over 2 or a y value of radical 3 over 2. Look at the unit circle and find all places where the y value is radical 3 over 2. So you personally don't need to jot down what I wrote down, but I thought that'd clear up what we're looking for. We want all of our y values to be radical 3 over 2. So you're kind of going on a treasure hunt. They're going to find 2 places on the unit circle that have y values of radical 3 over 2. And we're going to write our answers in radians. So the first place I'm seeing is up there at 60 degrees. So I'll write down its radian equivalent, pi over 3. And the other place I'm seeing is over, it's a reflection image actually, over there in quadrant 2, 2 pi over 3. Now, we are going to add that tagline onto both answers because you can add or subtract a 2 pi and end up at the same location. So plus 2 pi n. You might be wondering why I'm not doing minus 2 pi n, because you could make n a negative 1 and that would cause you to subtract 2 pi. Okay, and those are your 2 answers. So maybe you guys can pause and catch yourself up if needed. Alrighty, go ahead and jot down this next one. We are going to start ourselves off by subtracting 4 to the other side. I'm going to write it in the middle of my board so I'm not up at that edge. Minus 4 minus 4, giving me 2 sine x equals 1. At this point, we're going to divide by 2 on both sides. And that will give us that sine x is 1/2. Unit circle time! Go on a treasure hunt. Find all places on your unit circle that have a sine value of 1/2 or a y value of 1/2. All right, you should find 2 places. Pi over 6 over there at 30 degrees, that's in quadrant 1. Let me jot that one down. And the other one over there in quadrant 3. No, sorry, quadrant 2. 5 pi over 6. 5 pi over 6. And don't forget to add your little plus 2 pi n, and that just means you could spin around another circle or several circles. As long as you're landing at the same location, you'll be landing at a solution coordinate. All right, let's go ahead and jot down the next one. It's getting a little bit harder. We've got cosine on both sides, so we'll talk about what we'll have to do with that. All right, I'm going to start by trying to get my cosines together. They don't want to be separate from each other, so let's do a plus cosine x here and bring him over to the left to join the other cosine x that we already had. Now, if this original one was 1 cosine x and this is another 1 cosine x, we now have 2 cosine x living on that left-hand side. Hopefully that makes sense to you. We are trying to solve for cosine x, so let's subtract this radical 2 to bring him over to the right-hand side. And then at this point, we'll divide the 2 over. And we're solved for cosine x, so we're to the point where we can look at the unit circle. Let's head to our unit circle. We're looking for all locations where the cosine value would be negative radical 2 over 2. So this time you're looking at the x value, the first half of the coordinate. We want the first half of the coordinate to be negative radical 2 over 2. So I think we're going to be in quadrants 2 and quadrants 3. Did you find any of the locations yet? I see one up at 3 pi over 4. And another one down at 5 pi over 4. And then we'll just add our plus 2 pi n, and the problem is finished. Hopefully you're having fun so far. These aren't too bad. I'm going to solve for cosine or sine, and then look at your unit circle. All right, we are on our last problem, so that's exciting. Go ahead and jot it down. Cosecant is going to be a little bit unique of a challenge, but we'll get through it. So before I even start, let's discuss cosecant. Who is cosecant the reciprocal of? Just shout it out. Who is cosecant the reciprocal of? It is sine. It's the reciprocal of sine. So keep that in mind as we're working. Let's start ourselves off by dividing both sides by 3. Ooh, that was supposed to be a 3. You know what my board is. We've got cosecant squared x equals 4/3. Our next job is just going to be to square root it, because that will solve for cosecant. Cosecant x is the positive or negative 2 over radical 3. Because the square root of 4 equals 2, but the square root of 3, that's not a perfect square number, so I'll just keep it as a radical 3. All right, it's time to put that reciprocal into action. We do know that cosecant x is equal to 1 over sine. So if I was curious and I wanted to know what sine was, I would just reciprocal both sides. So I can reciprocal the cosecant, and I can reciprocal that 2 over radical 3. So that's going to give me positive or negative radical 3 over 2 is equal to sine x. It's kind of like you flipped them both upside down. At this point, you can look at your unit circle again, looking for y values of radical 3 over 2. I feel like we already did that earlier on. Yeah, we absolutely did. Those two locations is pi over 3 and 2 pi over 3. I actually lied to you. There's more than 2 locations. We're looking for positive and negative radical 3 over 2 for our y value. So there's actually 4 locations. Pi over 3 is your first one. That's a positive radical 3 over 2. 2 pi over 3 is your second location. That's a positive radical 3 over 2. But then if you're looking for negative radical 3 over 2, there's going to be 2 more solutions down in quadrants 3 and quadrants 4. So 4 pi over 3 is another location. And then the last location is 5 pi over 3. Probably want to add our little tagline plus 2 pi n on every answer. And then that's it. That's a big answer. You look super scholarly with that on your paper. Woo! Good job. All right, so your homework to work on at this point, the substitute will pass out. It's the 10.4 day 1 worksheet, and you only have to do the front half today. So thanks for watching. It was a 14-minute video, not too bad, almost 15 minutes. Have a happy Tuesday, and see you tomorrow.